Let's go back here. Oh, okay, cool. So let's talk about object inheritance. So what is it? This is from Wikipedia. So in most object or class-based object-oriented languages, it's the mechanism for which one child object acquires all properties and behaviors of a parent object. So that's kind of the CSE explanation. You might have heard someone explain it that inheritance is it should be used for an is-a relationship. So a duck is a bird, where duck would inherit from bird. Or you'll hear like dog is an animal or some sort of relationship like that. So inheritance, in Sandy Metz's definition, is for specialization and not for sharing code. So this is kind of the first no-no of inheritance, of why people misuse it, is a lot of us learn beginning that we should write dry code, that we shouldn't repeat ourselves, right? So inheritance is a neat little trick to get away from duplication. So that's a really big error that a lot of us make.
So specifically, what do you mean by sharing?
So sharing code as in I don't want to write this function twice.
So it's just related to dry.
Yep. Yeah. So what I've learned, and this is opinion, this isn't fact, what I've learned through my experiences and through talking to people a lot smarter than me is duplication isn't necessarily a bad thing. And you shouldn't jump to an abstraction early. You should wait and make sure that you're making the right abstraction. Just because you repeat one line of code or one method doesn't mean like, oh, this is a red flag, you got to fix it right now. Sometimes it's best to just wait it out a little bit and wait for something more obvious to present itself.
It's really two things that are intrinsically similar, or it's just that they're two things that coincidentally need to do something.
Yeah.
And that helps me make it.
Yeah.
Yeah, a mentor I work with at my work, he has just made it up. We call it the rule of 4. It's like if you do it once, that's fine. If you do it twice, same thing. It just could be something. 3 times, it's the 4th time, then I'm okay to go and simplify it.
Yeah.
Not repeat myself. But before that, he actually has totally figured out that you're just wasting your time digging into a problem that probably isn't even there, that you solve by writing it twice, or it actually has a reason for being there.
Yeah. Yeah. And oh, go ahead. Thank you. Yes. So, and it's really important to recognize as human beings, like we're inherently, we want to find patterns. That's what we want as like we want to find a safe habit that we can. It's in our in our DNA. So it's very easy for us to spot something that looks similar enough that we think it is an abstraction, but like you guys are saying, like we should really wait for it to be an obvious thing that is really painful that we need to fix. Oh crap! So I wanted to show this. Hopefully the
Sandy Metz rocks, by the way.
Sandy Metz is my favorite.
DigitalOcean's cloud computing platform was designed with simplicity in mind, giving development teams the item.
Okay, so just a little prep. So this is by far, I think, one of my favorite conference talks I've ever heard. I cannot recommend that you watch this enough. It blows my mind. Sandy Metz is also awesome. If you haven't read Pooter and more, like I just read 99 Bottles of OOP. They're amazing books. Like 99 Bottles is by far like the most helpful book I've ever read in programming. Like the way that she lays everything out, I cannot recommend that enough. So we're gonna watch a little clip. This is going over code kata. But this is just Sandy Metz kind of talking about why she's choosing inheritance for this problem. So what I really want you guys to get out of this is there is a use case for it, but there's very strict rules, and it's a tool in your toolbox, not something that will solve everything. So
the other talk that's on there too, the Nothing is Something, is a great talk.
Very good. Yep. Yeah, Sandy Metz is awesome. She rocks.
Now, despite what you may have heard, inheritance is not evil. And I can tell you exactly when it's safe to use it. Here's what you want. You want a shallow narrow hierarchy. You don't want it to be deep, and you don't want it to be wide, right? Shallow, narrow. You would like the subclasses to be, okay, this is, I'll say this twice. You want the subclasses to be at the leaf nodes of your object graph, right? So you have objects and about other objects and about other objects. Down at the end of your sort of tree, there are objects that then don't know about any other things, right? So we want the subclasses to be the leaf nodes of the object graph to be at the edge. And we want all the subclasses to use all the code in the superclass. Now I'm going to repeat that again. Shallow, narrow, subclasses at the leaf nodes, and subclasses use all the behavior in the superclass. If that is the problem you have, there is no better solution than inheritance, and you are free to use it.
Okay, so I wanted you to hear it from her and not me because she's way more authoritative than I am. But if you read on the internet and if you listen to a lot of these arguments against inheritance, you will not hear arguments against what she just described. You will see super deep hierarchies, super wide hierarchy. You'll see all of the wrong reasons, and they'll argue against it. And it reminds me of Fox News, and it's why I wanted to give this talk. Like, there is a use case for it, but it is very specific. Okay, let's go back.
What are you saying about Fox News?
I love Fox News. Cool. So let's look at what inheritance is in Ruby. So we have single inheritance, which you guys should be familiar with the less than sign. So we have a parent class. Sorry if you can't read these comments. So you've got a parent class, and then we could have a child class that would inherit from that parent class. And then this is the ancestor tree that I was talking about earlier. So you can actually call .ancestors on a class, and you can look up what its ancestor tree is. So we can see that child first responds to itself. It will then look at parent. It will then look at object, kernel, and then basic object. And this is every single class in Ruby will look like, at least look like from this step down. So everything will inherit from object, kernel, any class, sorry, will inherit from object, kernel, and basic object. So that's just how Ruby is built. And kernel, like we saw earlier, is where we get a lot of those methods like puts, sleep, kind of things that you don't think about but that you can use freely. So we also have multiple inheritance. And a lot of people don't realize that when you include a module, you are using inheritance. You are using Ruby's solution to multiple inheritance. This is probably the bigger evil of the two because you can get into a lot of unpredictable circumstances just depending on how the module is included. There's just a lot of ways for you to not understand what's going on, and you can build some really scary stuff that's hard to maintain if you include a lot of modules. So word of warning, but opinion as well. So this one, if you can't see it, we've got child, parent, object, kernel. So it's literally the exact same as before. The difference is we can include multiple, we could have multiple include statements, and we could obviously have multiple inheritance. This one I wanted to call out. You'll see this in a lot of code too, where we're wrapping child in a module. This isn't actually including the module, we're just namespacing. So when you call this code, you have to access it through the namespace. So it's not like you're doing anything. You could have another class called parent. You're not actually accessing any parent methods, you're just namespacing that. So we've got parent, child, looks just like that if you can't see it, and then object, kernel, basic object.
Which helps you prevent collisions and things.
Yeah, so it's a great tool, absolutely. It also can help you with just grouping in a lot of other, so in Elixir, Phoenix, the framework that's most like very similar to Rails, they kind of ship with this idea of bounded context, which is kind of what you can do with these namespaces, is you can try to wrap a bigger idea in a namespace so that you can break it apart in your system and kind of have a better modularization of your system. All right, so why do we use inheritance? This is kind of if this is a pro, I mean, we can define relationships in the domain. If your hierarchy's right, it can tell programmers about the actual class relationship. Removes duplication. I threw this in here as a red flag. Like, I would say that's a side effect. It's not why you should reach for it at all. But you can get rid of a lot of boilerplate code if you're in the right circumstances. So cons, there's a lot more of them. So when you inherit, you're literally creating a coupling, right? Like there is no tighter coupling. Reduced readability, we saw that earlier with the example where you might not know where a method's defined. You might be surprised at what's responding to a method. Easy to abuse, a lot of people use it wrong. And then it can complicate testing. And what I mean by that is it makes it harder to isolate, to test in isolation, which is what we want to do. You don't, unless you're in an integration test. So I should say unit testing. So if we're unit testing, we want to focus on a single thing and test that single thing and not what it depends on. All right, so let's talk about composition. I personally had a hard time understanding composition when I first started trying to learn it because it's so simple. And I just kept thinking that I was missing something or I wasn't getting it, but we'll go over it. It really is pretty straightforward. So what is composition? So it's a way to combine simple objects or data types into more complex ones. So you can think of it pretty simply. A car is a good example. A lot of people use this. I might actually have that on the next slide. Yeah. So it should be used, you might have heard people say it should be used for a has-a relationship. So a car has an engine, where the car would be composed from an engine and a steering wheel, and it would have these different parts that you'd build up this larger thing with. So let's look at composition in Ruby. So we have, in the broader computer science, we have functional composition. You can think of it as method composition in Ruby. This is basically anytime you're chaining methods, you're composing functions, you're composing methods. So this one's as simple as it gets. We're calling toString, lowercase, and gsub. So we've composed a function with all of those other functions. So it's the same thing. Like this sanitized name is made from all these other things. So it's a large thing made from small things. And this is kind of not talked about in Ruby that much, but it was worth bringing up. So this is what we really want to talk about is object composition. If you look at this example, we have a user class with an initializer where we can pass a role into it. That's as simple as it gets. That's composition. So instead of defining default role inside of our initializer, we're allowing a place for us to inject whatever type of role we want. So this is very important in Ruby because of things like duck typing. We won't really get into it, but it's the simple idea that instead of having a class define itself, we're actually going to reverse the dependency and we're going to put it into it instead of having it live inside of there. And we'll go over why some of the things we can do with this and why it's preferred. So composition is flexible. Like you can pass in whatever you want. You can change your test. You can change anything, right? It's as flexible as you can get. It's very readable because it's all there. There's no hidden anything. It's all in front of you, and it's explicit. There's literally nothing that you're abstracting or hiding away. It's all there for you to see and understand. And then the cons is you got to write more code. If you're setting up a bunch of initializers, it's going to take more characters. But I don't really think this is a con. I just thought it was something worth calling out. Sweet. So we're going to talk about trade-offs. I've got an example. Okay, cool. So hopefully this is a simple example. Everybody see this? It's probably not that great. I might be able to bump up the font size. Okay, sweet. So we've got some boxes, as simple as I could think to make it. On the left, we are using inheritance. On the right, we are using composition. So, oh, no, we're not. We're inheriting there too. Oh, boy. This must have got undone or redone. So ignore that. Should not be doing that.
We're now live coding.
We are now live coding. So what I wanted to show here.
Do you have tests?
No, there's no test for this. So what I wanted to show here, that initializer should be gone too. I don't have any of this stuff. I opened the wrong file. Nope. All right, I'm sorry. Something got messed up.
No, you just say.
So yeah, this might not be what I wanted it to be. Make sure that looks right. It's still kind of, I must have just undid or something. Okay, sweet. So the big differences here are in the inheritance version, we're trying to set up this object that has a bunch of defaults that we think are safe. So we're setting up our adder reader, which is just going to allow us to access these initialized values, and then we're setting defaults on these. If you compare that with composition, we're still going to set an adder reader for the two things that we don't think are going to change. So we're not necessarily going to derive that from what we pass in, but we're also going to take a box object. So we're going to inject a box. So instead of just defining it in line, we're going to defer to what we pass into it. So this will give us the flexibility to create things and then actually pass in different values. So as we go down, you'll notice that small box, if we want to change some values, we're going to call super, which is then going to call box's initialize method. So it's going to set all this stuff up for us, and then it's going to override our width and height. So we do reduce code because of the inheritance, but we also lose a lot of visibility. If this isn't a normal example, you're not going to see the parent next to it. It's going to be in a different file. So we obfuscate things. Over here, you'll notice that it's pretty much the same. We're going to override some stuff, but we're going to defer. So we still have to give it all of the values. We're not able to fall back onto a parent. So that's where the more boilerplate comes from, is you have to be explicit. There's no magic with it, which is a benefit. Same thing with big box. We're just going to do, okay, so this is wrong. This is right. So we're just going to derive all these values. And then we get into something like plastic box, where if all we want to override is material, you can see this one's super short. We're just overriding the material to plastic. Whereas this one, we have to go through and set all the values, and we also have to set plastic. So it's just more explicit. And you can also see, so I've got like a tiny box one, but it's pretty hammered home. Like I think you guys can see the difference. So yeah, that's a pretty big difference between the two, where you're just being very explicit about the composition, and then you've got hidden gems in the inheritance.
In your initializer that you're passing in box, where's the box per se defined?
So that's the amazing part. So I used to have, I probably don't anymore. So if we wanted to use plastic box, for example, we could say our box is going to equal, it could be anything. So as long,
Well, it can be anything, but it has to have size.
so exactly. So this is duck typing. So this is kind of another topic, but we can pass anything into this initializer that responds, that has the same API as what we're expecting. So it could be an open struct, it could be a class, it could be a lot of different things. So as long as it'll respond to these methods, so this is duck typing, if it walks like a duck, talks like a duck, like that's what they're talking about. So it doesn't matter what it is, as long as it responds to those, we're good. So we could do something. Let's actually get try going. Let's go into, oh boy.
Really good for some.
Yes, sir. That's not gonna work at the bottom. Oh well. Can I? Let's see if I can do this. Okay. So if we want to create, so say we want to create this plastic box. I'm going to do a, so let's say box is going to be an open struct. And I'm going to pass it width 50, height 50, hope I'm spelling all this right, sides 4, and a measurement unit of inches. Oh no! Oh, do I need to do that new? Oh. Okay, thank you, Ben. Okay, sweet. So all this is, it just gives us a kind of a blank object where we can call box.width and get 50. So it responds to those messages so we can use it. So I can come in here and I probably have to require, and I can use the right quotes, cheese. Load. Okay. So I can come in here and I should have plastic box. I do. So now I can say I'm going to create a plastic box. And I'm going to pass in the box that I have as a local variable. And now I have a plastic box. So this is where you see the flexibility. So I'm going to go into another example later where this will be a little bit more helpful. But it gives you that flexibility to use a class. You could swap something different out in your tests if you want to stub something. So it just gives you the option to use something different, which is a great benefit. Is any of that unclear? Anybody have any more questions or before we move on? Cool. I thought I'd threw this slide in here, like single table inheritance. This talk isn't about single table inheritance. My opinion is you should avoid it, but do your own research. So talk's not about single table inheritance. Cool. So I've got another example that I can show you guys, but I kind of just wanted to open up to questions. If there's anything like you guys were hoping I would cover or didn't cover or didn't go too deep into or anything anybody's missing. You're gonna go there.
A while back, there was a very heated discussion in the Iraq channel about it.
So
same reasons.
Yeah, so for those of you who don't know, single table inheritance is inheritance kind of taken to a database level. So it's a way for you to share database tables the same way that you would share code in a normal Ruby file. My answer to that is I've been told by people that I trust and respect not to use it. Maybe. So the advice I was given.
So Cody used to work at a company who
offer label.
Who let's put it this way, over-engineered the entire database. There is a use, like everything. We never deal in absolutes, in my opinion. There's the easiest example of where single table inheritance makes sense is if you're talking about something like an address that might be a billing address, it might be a primary residential address. It's the same data represented different ways. That's a good example of where you might actually use single table inheritance because at the core data level, the only thing that's really different in there is the type of address that you're referring to it by. But an address is an address is an address, and that has been pretty well defined. Where it gets super fuzzy is if I have 20 different types of users, should I really do that? Or if I have
That's ugly.
And then it's time to insert your own opinions about all of that. It all depends on the use case.
Yeah.
Fair?
Yeah.
So I would almost argue the fact that if you're not defining the parameters of what it is you're representing, it might be an okay use case for it. Like the industry, the world has defined what an address is, right? The world has defined what a text message is. But payments, that's up to your own interpretation. A payment might be credit card, it might be crypto, it might be check, it might be ACH. These are all very different things.
Purchase order, invoice order.
Right. It might be a payout rather than an incoming.
So I think a safe thing, like don't use it to save columns in your data. Like data's cheap now. Like that shouldn't be a reason to use it. Is that fair?
It's true.
That's fair. But there's also better ways to get data, right? If it's that important, maybe the database isn't the best place for it. You should be using an index somewhere, if that's the priority.
She doesn't like single table inheritance.
Okay, cool. Well, that's all I've got. So oh, cool. Common denominator. No. So
No, I think that's actually saying it the other way.
yeah, so a lot of people explain this as like the gorilla and the banana problem, where you want the banana, but instead you get a gorilla holding a banana, and that's not what you want. So if you're not using everything that the parent defines, then you probably shouldn't be subclassing it. So if you just want a banana, don't get a gorilla holding a banana, just get the banana. Does that make sense?
So I think what you're saying is that the subclass is an extension of the original the parent.
A specialization.
But what does that do? Well, that handles a whole lot of
Freaking right. Could be.
But you can multiple inherit.
Right.
What do you think,
So
George?
while you can't with the whatever less than sign, you can be an
It's actually funny. You sort of answered your question, making fun of her when the baby cried again, because you said it's the lowest common denominator. And I think as like pattern matching biological beings that survive on that we can see like that a tiger is not the same as grass. We're going to be eaten. We've tried to pre-optimize the lowest common denominator, and we're wrong a lot because we're like, oh, those are so common. It's like, well, they're not the lowest common denominator. Yeah.
Another important thing to realize is like one of the hardest parts of programming is naming things. Like we're all pretty bad at it, right? So like if you're trying to create a taxonomy of things, naming them correctly probably wasn't the strongest thing that you did. So it's a bad way to go. But
I'm great at naming things.
Does anyone else understand
What? How does that actually work out in Ancestry?
dot ancestors,
Multiple inheritance.
it'll literally
Stack 'em.
depending on order. Yeah.
I mean, one could argue that's just style preference. Do you want less than this, or do you want to write includes this? It's the same thing.
Yeah, fundamentally.
I'm not trying to say this is a comment. It's a
those 5 methods are getting long. Along with anything that so it goes all the way up the tree. Everything that it has is long. But just pull up any model. Oh crap, that's not even me. Or like people in the tab and stuff like that. And autocomplete never does because of all the methods that have been inherited by that.
Yeah.
And that's
Well, I mean, but to your point is kind of Rails teaches you inheritance by facility.
And Rails is not following.
Right. And Danny, to your point, I don't know if it always makes sense to insert composition in the middle of all of your inheritance things that are happening in a Rails project. It's just kind of adding like superiority to the code base or something like that. I don't know. Maybe it does, maybe it doesn't, right?
let's say you want to all these one approach would be to make all of them inherit one base class and another approach would be an animal class that has one method. Anything into it. Then if there's, as long as then you can use the run. And you don't have this tree that you only created just so everything. That's the real point. You don't want to create a tree. Inheritance is the
Install it.
and you don't want to create that whole tree just so that you can.
Does anyone here do a lot on JVM stack? I don't care if it's Java, Scala, whatever. No, okay. I was wondering what that opinion would be on composition versus.
The thing to keep in mind too is that one of the first things he says is that, there is no one answer. It's situational. And I've been doing this for a long time, and every developer that I've ever really known is anything. So we all have our opinions about right and wrong. And they're all right or wrong. So it just depends on the situation. What works for you? How can you write maintainable code that's readable, easy to understand? Her other book is really good too.
So yeah. So I'll leave with this. So this is really a talk about object-oriented design. So if you want to learn more about object-oriented design, like this book, this is basically Pooter 2. But I think to me, it was a lot more understandable, a lot more digestible, and it was really fun to follow along with. Like I was actually writing all the code as she was talking about it. And it's really cool to see it's basically a refactoring exercise, and you get to participate the whole time, and it's really fun to see what she takes you through. So I'd read it. It was like 50% off, I think, but I have no idea.
I'm actively trying to get Sandy
Yeah,
to speak at CAC.
till the 13th. So, happy birthday. I think it's her birthday or something.
I'm actively trying to get Sandy to speak at one of the future Ruby Hacks. I talk to her each year, and she keeps saying she wants to do it.
Oh, yeah. Nice. Super good. Yeah, so there's all the small things. What was the other one? Nothing is something.
Yeah, nothing is something.
That, yeah. Yep.
Yeah, she's responded each year. She says she wants to talk at Ruby Hack. Her schedule hasn't been able to. So I'm going to hit her up early this time.
Maybe next year.
It's normally too close to Rails comp, probably.
That's part of the problem. 2 years ago, she was doing something in Australia.
Cool. Well, that's all I've got. So thanks.
All right, anyone want to break the politically correct barriers and have a fun discussion about this? No.
But it breaks the rules that she said to start with.
Oh, yeah.
Narrow and shallow. Yeah.